Okay, so now that we've talked about the fundamental theorem, part one and part two, though those may be backwards, we're now going to talk about what integration means in terms of actual context, in case. And you're going to be asked about particular problems. So we have particular problems here on this entire example two, where it's asking us to kind of break it into bits and pieces and see exactly what they're talking about here. All right, so we'll do some typing here. Okay, now, so for example 2A, it says if f of t represents the rate at which your 401k changes over the month of January, then it's asking about the units of f of t. Well, f of t is the rate. So this would be like, I don't know, what are we going to say, dollars per day? That sounds pretty good. That's what f of t is talking about. It's the rate, and a rate is always in some sort of unit, and most of the time some sort of unit of time as your denominator. All right, now if we throw a dt in there, that's the thing that's changing. That we were trying to. It's our interval. So our interval would be the days. So if I multiply those two together, guess what you got? Dollars, because the dollars per day times the days cancel out the days. And so then that means now that this integral would represent the value if of your 401k dollars for the month of January. We're talking about a net change here. So it's a total change in the value. So sometimes it goes up, sometimes it goes down, but this integral would tell you the end result, what your total change was for the month. Yeah. All right. Very nice. Okay. Next one. If R of t represents the rate at which your pizza changes in a 475-degree pizza oven 5 minutes after the pizza has been placed in the oven to cook, then what is the integral from 5 to 20 of R of t dt? Well, that would be the total change in the temperature of the pizza in degrees Fahrenheit. Fahrenheit. I'm sure there's a shortcut button for that somewhere, and I just don't see it. So we're just going to type it that way. From t equals 5 minutes to t equals, again, the change. It's the total change in the temperature. And, who knows, more than likely, that's all going to be positive amounts as far as the rate goes, as the temperature is increasing for the pizza. But you never know. It might hold steady for a little bit and you have some fluctuation. But this is saying the total change, from the beginning to the end. Okay. All right. C. Your friends are planning to buy a ticket to your favorite musical group, the Newtons. Everyone wants to hear the latest hit. Why integrate? A of t represents the rate at which students are arriving at the ticket window. P of t represents the rate at which they buy their tickets and enter the concert. All right. So now notice A of t was the rate in which students were arriving. So 1 to 5 would be the change. Oh, no, sorry. The number of students arriving to get in line from 1 to 5 minutes. Yeah, it's gonna tell you the total number. Okay, so the number of students arriving to get in line from t equals 1. Does it say? Doesn't say what the time measurement of time is, but that's okay. All right, so from t equals 1 to t equals 5. I'm assuming that might be hours. Who knows? All right. So then what about p? All right, that integral would represent the number of students that have bought tickets and left the line from t equals 1 to t equals 5. Okay. All right, if you subtract them, you've got the people that entered the line and the people that left the line. So this would be the A of t minus P of t. Now those are still in terms of rates. We don't have any integration here. That's going to be for number 4. All right, so A of t minus P of t would just be the rate at which the line is growing or shrinking. Because who knows? So, because at that moment, it could be that people are leaving the line at a greater rate in which they are entering. Who knows? We don't know what the function is, and vice versa could be true. So the line could be growing or shrinking depending on whether that's positive or negative. If that's positive, the line is increasing. If it's negative, the line is decreasing. All right, and so then now we want to know how many people are in the line, the total change of people in the line, or the length of the line. Oops. Come on. Of the line from equals 1 to equals 5. Total change. All right. All right. Here we go. D. Recall that velocity v of t represents the velocity where your positive direction is to the right. Velocity is the rate in which position is changing. Okay, so this would be the total change in position from t equals 5 to t equals 50. Okay, I think in her note she says on the interval 5 to 50. I mean, there's just different ways you can write it, but that's another option. All right, and again, we don't know what the units are here. Okay, position from t equals 5 to t equals 50, and I don't know what the units are. So whatever they are, we would do that, which has a special name in math called displacement. And if you've had any physics, you've dealt with that a little bit before. All right. So displacement is what we're talking about here. Now, it's not the total distance traveled, because there could have been some backward stuff, right? It's the total displacement. Like you drove, maybe some of it was backwards, some of it was not. This integral will tell you, and we've seen it before, area under the curve, positive and negative stuff would cancel each other out, that kind of thing. We don't know. It's displacement. It is not total distance traveled. Okay. All right. So likewise, A of t is the rate in which velocity is changing. There we go. And that would be the derivative of the velocity. We've done that before. Okay, that's it for example 2.